In this video, we're going to take a look at concentration of solutions, percent by volume and percent by mass. So we've taken a look at the molarity already and how that relates to the number of particles that is dissolved to the volume of the solution. So here's a couple other ways in which we can look at the solute to solvent ratio. So percent solutions, we look at percent by volume and percent by mass, getting a ratio of the volumes of the solute versus the solution and the mass of the solute versus the mass of the solutions. So to solve for the percent by volume, again, it's just a part over whole ratio. The volume of the solute that's dissolved into the volume of the entire solution times 100%. This is probably one you see more frequently. Take a look here at hydrogen peroxide is 3% solution. So of that bottle of hydrogen peroxide, it's 3% hydrogen peroxide, 97% water, making up that entire solution because it's a much more diluted down solution. And we can do the same thing with mass. Take the mass of the solute over the mass of the entire solution times 100%. Again, just getting a ratio of the mass of the solute versus the entire solution that it was in that solution. So let's take a look at one of each of these types of problems. First up, we'll look at percent by volume. So we're going to take a mixture of ethanol, C2H6O, and we're going to take 85 milliliters of ethanol. We're going to dilute it up to a volume of 250 milliliters with water. So what do we know and not know? Well, we don't know what the percent volume is. That's what we're looking for. But we do know we have 85 milliliters of ethanol, which is our solute, that is then in a solution of 250 milliliters. So we can just use those since they are in the same units. They're relative to each other. We can just find our percent using those two different measurements. We know our percent by volume is the volume of solute divided by the volume of the entire solution times 100%. So we're already solved for percent by volume, so we can just use this equation as is and substitute in for our variables. The 85 milliliters of our solute, the ethanol, over the 250 milliliters of the entire solution times 100%. We find this to be 34% ethanol by volume. So that was a straight, again, just plug and chug. We already had it manipulated the way we needed to. We didn't have to do any conversions. So let's take a little trickier one here when we look at mass. So we want to make a 2,000 gram solution of glucose that is 2.8% by mass of glucose. How much glucose should we use? So again, let's list out what we know and we don't know. We know we want a 2,000 gram solution that is 2.8% by mass. How much glucose should we use? So again, here's our equation. Percent by mass is mass of solute over mass of solution times 100%. But we're not solving for the percent this time. We have the percent. We're solving for the mass of our solute. So we're going to do a little bit of algebra here and manipulate this equation to solve for our mass of solute. So first thing we're going to do is divide both sides by 100%. Move that percent to the other side. And then also, let's move on the solution. And we're going to multiply both sides by the mass of solution. So now the mass solute is isolated. And we find it to be the mass of solute is the mass of our entire solution times the percent that we have divided by that 100%. Again, just taking that percent, changing it to a decimal. So it's really just taking a percent of a whole. And again, now just substitute those in. Really want 2.8% of 2,000 is really all this question is asking. So 2.8% as a decimal, again, dividing by that 100%, the percents go away. 2.8 divided by 100 is 0.028 times the 2,000. We find it to be 56 grams of glucose that are needed to make this 2.8% by mass solution of glucose.